help with that? Were you good with that?
I'll watch it.
Okay. Yeah, you can leave it if you want. It doesn't really matter.
All right, it's almost 5, so
You're welcome to stay as long as you want. If you want to keep working, you don't need to leave. You want to stick around. But if you need to go ahead.
I'll go through.
Okay. Okay, so we are doing rational functions.
Yep.
So we are going to find the domain, the range, all that good stuff. Well, the first thing to do always with rational functions is to factor. So let's factor the top and bottom if possible. And it looks like it factors into -5 and +1.
Yep.
Right, we good with that? So that just, it makes it a little bit easier to see because the domain, actually the domain and range I do last. Let's just hold off on those.
Oh, okay.
What I do first is I look for RD, and the RD is where, I'll put the notes on here. It's where factors that cancel.
Yeah, and there's nothing that cancels, so there's no RD on this one.
Correct. Factors that cancel are what would give us RD, so we have none here.
All right.
The horizontal asymptote, we'll deal with that later as well. The vertical asymptote is where the denominator, set the denominator equal to 0.
All right, then that's X also. So now be X is +3.
Yeah, so X minus 3 equals 0, which means X equals 3. There's my vertical asymptote. We're on Zoom. We're doing some rational functions. Are we still doing that?
No.
Are you done with that? Domain and or logs and exponents?
We're using sign analysis again.
Got it. So X equals 3, which is right. X equals 3 is a vertical line. So let's draw that in. So there's our vertical asymptote right there. The X-intercepts are the last, so the 3 things I do first are the things that have to do with the zeros. And those are these 3 things. The X-intercepts has to do with where the numerator equals 0. So I'm setting the numerator equal to 0, which means X equals 5 and X equals -1. Can you see that?
Yeah.
So let's plug those in. X equals 5 and X equals -1. Those are my 2 X-intercepts. Now let's do the horizontal asymptote. The horizontal asymptote has to do with the degrees of the numerator and denominator. If it's bottom heavy, meaning the degrees of the denominator is bigger, then the x-axis is your horizontal asymptote. If the degree, which is not the case here.
Yeah.
If the degrees are the same, then the horizontal asymptote is the ratio of leading coefficients, which
Okay.
is not the case here either. And if it's top heavy, meaning the degree of the top is bigger than the bottom, there is no horizontal asymptote. So I say none. But there is a slant asymptote. And that happens when the degree of the numerator, or the degree of the numerator, is equal to 1 more than the degree of the denominator. That's when you have a slant asymptote, a line asymptote,
Oh, okay.
which is what we have. And what you need to do is long division.
Yeah.
Have you seen that yet?
Yes, we actually.
So let's do that right now. So let's take X minus 3. I'll do that at the bottom. And I'm going to take X squared minus 4X minus 5. And I'm going to divide that into it. So here's how you do long division. How many times does this go into this? In other words, divide this by that.
There'll be 2.
Not 2. It would be X.
Oh, X.
X squared divided by X is X. Then multiply that here.
I'll see you next week.
Okay.
So then that'll be 3X.
And you get, nope, X squared minus 3X, right?
Yeah.
And then subtract it. So that becomes that. I'm distributing that negative in, add straight down. You have -X minus 5. See how I did that?
Yeah.
And now same deal. this divided by this, what do you get? Negative x divided by x.
That would be -1.
Perfect. And you can stop. That's all you need to do, because there's your asymptote. So your asymptote is y equals
MX plus B.
x minus 1, right? X minus 1, which means it goes through this point right here, -1, and the slope is -1. So it's going,
Well, it's got a negative.
oh, it's a +1. The slope is +1.
Oh, right.
So there's your asymptote right there. Now, hopefully that's all the information you need and you can graph it. And it actually is in this case. Do you know why it is?
Oh, because you have, your 2 points.
Actually, let's do the y-intercept. We might as well do the y-intercept as well. The y-intercept is you let x equal 0 and solve for y, just like we've always done. So when I let x equal 0, I get, what is that, a -5? I get 5/3. 0, 5/3, which is 1 2/3, which is right there, and that checks out. That works out. So our graph now, if we graph it, you can see that it's going to have to go like this because it always has to approach a vertical asymptote. And it also has to go up here because it always has to approach toward infinity. As x goes to infinity, it has to approach the slant or the horizontal asymptote, whichever it has. It's not going to have both. It's going to have one or the other, slant and horizontal. Can't have both. It can have vertical asymptotes and multiple ones, in fact. So this has to go this way, and it has to go this way. Do you see?
Yeah.
So here's my graph. It's something like this, and you're just basically sketching it. It doesn't have to be perfect. But this is going like this and like this. Got it?
Yep.
See how we did that?
Yeah.
So for this one, let me just talk you through and then I'll let you do it. What's the horizontal asymptote going to be? Remember what I said about Hassie's? It has to do with the degrees.
All right. So since it's x²/x², they're same power, so it'll be 1.
Perfect. 1/1, which is 1. That's right. And if you factor them, factoring, see how factoring comes in handy? Yeah, it doesn't ever end.
Factoring, oh my
And
god.
if you factor the top, let's see, are we gonna have something cancel out? I bet we will.
+3 and -4. So yep.
Other way around. +4 and -3.
Yeah, sorry.
So we are gonna have an RD because what cancels?
X plus 4.
Yeah, so your RD is gonna be -4, comma, whatever you get when you plug that into your new equation. X minus 3 over X minus 4. That's your new equation. So plug in -4 into that, you get -7 over -8, which is 7/8. So there's your whole, -4, 7/8. And I'll let you finish that. Okay,
I just have
and I'll check
this
it back.
question and then that's all I have.
Hold on 1 second, let me stop this.